Tonight, I want to ask you something soft but strange. Have you ever looked up at the sky and really wondered, why is it black? Not blue like during the day, not grey like a storm, just deep, quiet blackness. But here's the strange part. It only looks that way. The truth is, the night sky isn't actually black at all. It never was. In fact, what you're seeing, or what you're not seeing, is one of the greatest illusions in the universe. A trick of our biology, our physics, and our place in space. And once you understand it, the darkness will never feel empty again. So settle in. Maybe you're curled up in bed, or lying on the couch under a blanket. Wherever you are, just breathe. Let your shoulders drop a little. Let your thoughts slow down. You don't have to figure anything out tonight, just listen. And maybe, just maybe, the sky will feel different when you wake up. We'll start simple, with the question almost no one asks: why the night sky isn't truly black. At first glance, it's obvious. Look out the window tonight and the sky is black, a curtain pulled over the stars. But what if I told you it only appears black because of how little we can actually see? The sky is full of light, but our eyes only detect a thin slice, what we call visible light. It's like listening to an orchestra, but hearing only one flute in the far corner. Infrared light, ultraviolet, X-rays, microwave radiation, they're all still out there, shining gently. We just don't feel them with our eyes. Even during the day, space is still glowing. It's just that the sun overwhelms everything. And at night, you're not seeing a true black, you're seeing a sky without sunlight in your narrow range of vision. The rest just keeps glowing silently, beyond our senses. This illusion, this idea that no light equals black, is more of a human shortcut. We fill in the blanks with darkness, but the universe doesn't stop just because we can't see it. It hums, it shines, it goes on. And when astronauts float far from Earth, they often describe the sky not as black, but as oddly alive, full of depth, as if it's not dark, just not made for our eyes. That thought alone is enough to shift how you see your own ceiling tonight, how our eyes perceive darkness. Now let's turn inward, because if the sky isn't really black, maybe the real mystery is how our eyes decide what darkness even is. Human eyes are beautifully flawed. We're built to survive on Earth, not interpret cosmic truths. Our retinas contain rods and cones, light-sensitive cells, but rods dominate in the dark. And here's the twist. Rods can't detect colour. So in low light, we literally lose colour perception. And what do we replace it with? Black. That means the sky could be blue, red, violet, or glowing with radiation. But in the absence of cone-activated brightness, our brain says, just call it black. Simpler that way. We also adapt over time. Ever walked into a dark room and slowly started seeing? That's your rods adjusting, stretching their limits. But they never see everything. The sky's full orchestra still plays. We just hear the quietest notes. And then there's the psychological layer. Darkness carries emotion, emptiness, calm, sometimes fear. It's not just vision, it's mood, memory, instinct. So when you gaze at the stars and feel small, it's not just because of distance, it's also your ancient biology whispering. The sky isn't dark. Our brains just make it that way to help us feel oriented. But beyond that, the universe is still glowing, still calling. The myth of empty space. Picture space as nothingness. Black, cold, endless silence. That's the version most of us grew up with. But it's a myth, a beautiful one, but still a myth. Space isn't empty, it's filled with particles, waves, invisible light, and ancient heat left over from the very beginning of time. The space between galaxies is full of plasma, dust, energy fields, microwaves, gravity, things you can't see but that move, swirl, ripple. Even in the darkest pockets of the universe, photons drift, sometimes for billions of years before ever meeting anything. And in every cubic inch of nothing, there are neutrinos, tiny particles streaming through you right now, thousands of them, every second. What we call black is just beyond detection. We think of empty space like a room with the lights off, but the room still has furniture. You just can't find the switch. The sky isn't black because it's void. It's black because we're blind to most of it. And in this blindness, there's wonder, because knowing space isn't empty makes it feel alive, dynamic, breathing. Like behind the curtain of darkness, the universe is still dancing, just out of view. Why the sky glows in orbit. Here's something astronauts say often. The sky glows in space. It's not black. It glows. It's one of those quotes you might miss, but when you hear it, it sticks. Because once they leave Earth's atmosphere, astronauts don't describe pitch black nothingness. Instead, they speak of a soft, permanent shimmer, a kind of dark velvet flecked with life. Why? Above the atmosphere, there's no air to scatter sunlight, so the blue sky vanishes. But you're surrounded by starlight, radiation, and the subtle ambient glow of the universe. In low Earth orbit, there's zodiacal light, a faint haze caused by interplanetary dust reflecting sunlight. And Earth itself adds to the glow. Cities sparkle, the aurora dances, even lightning flickers on cloud tops. So from space, darkness isn't absence. It's filled with gentle presence. Like the stage lights are low, but never fully off. This glow isn't just visual, it's emotional. It reminds astronauts that they're not floating in death. They're floating in light. Invisible, subtle, eternal light. It's not black out there. It only looks that way. From here. What is light, really? If we're going to talk about the colour of the sky, we need to understand the brush it's painted with, light. But here's the twist. Light isn't really a thing, not in the way we imagine. It's a wave. It's a particle. It's energy that sometimes acts like matter and sometimes doesn't. Light travels at a constant speed, the fastest in the universe, and yet it has no mass. It can push objects, yet pass right through others. When we say light, we often mean visible light, but that's a sliver, like one string in a 100-instrument symphony. Beyond it lies ultraviolet, infrared, gamma rays, microwaves, X-rays. All light, all real, all just not visible. And light isn't always seen. Sometimes it's felt as warmth. Sometimes it bounces off dust for thousands of years before arriving at your eye. Sometimes it redshifts, stretching with the universe, becoming fainter and redder until it disappears. So when you look at the night sky and see black, remember, you're looking through a stained glass window of perception. The sky didn't go dark. The light just changed clothes. And ahead in this video, we'll explore where that light goes, how it bends, and why the blackness above your head is anything but empty. The journey of a photon. Let's follow a single photon. Born in the heart of a star, it begins its strange, almost poetic journey. First, it spends thousands of years trying to escape the star that created it, bouncing, scattering, absorbed and re-emitted through a dense crowd of particles. A single step forward, 100 steps sideways, until finally it slips into the open sea of space. From there, it travels at the speed of light, which means as fast as anything can. It doesn't age, it doesn't slow, it just moves, endlessly. It may pass through gas clouds, reflect off planets, or miss entire galaxies by a whisper of space. Some photons reach Earth, and some of those somehow land in your eye, and for a moment your brain turns light into vision, into awareness, into beauty. But most photons, they never arrive. They drift in the dark, never meeting a telescope, a retina, a mirror. They keep flying. So when you look up and think, it's black, remember, you're not seeing a blank sky. You're seeing light that's still on the way, light that missed us by inches, light that may arrive tomorrow or never at all. How space bends colour. Now imagine space not as a flat sheet, but as something soft, flexible, because that's exactly what Einstein taught us. Space bends, and when it bends, light bends with it. This bending doesn't just change direction, it changes colour too. As light stretches, like taffy pulled too far, it shifts toward red. That's called redshift. And when it compresses, it shifts blue. So colour in space is a story of gravity, motion, and expansion. In deep space, starlight stretches so far it slips beyond visibility. A galaxy that glowed blue billions of years ago might reach your eyes now as a reddish whisper, or disappear entirely into the infrared. It didn't stop shining, it just shifted out of your range. Even black holes with their extreme gravity bend light so hard it curves back on itself. You could stare at the edge of one and see the back of your own head, light bent in a cosmic loop. And still your brain might say, darkness. But that darkness is layered, warped, a painting still in motion, a colour stretched by time itself. When the sun is gone but not gone, ever stood outside just after sunset and noticed the glow still lingering in the air? That's the sun, or at least its light, still touching the sky. Even when it dips below the horizon, its photons bounce and scatter through the atmosphere, colouring the clouds and tinting the evening in soft pastels. Now imagine that idea, but on a universal scale. Stars that no longer exist may still have their light crossing the cosmos. The sun could vanish, and for 8 minutes you wouldn't even know. That's how long its light takes to reach us. And beyond that, entire galaxies, long faded, are still visible, like echoes in light. We're not seeing them now, we're seeing them then. The sky isn't a live feed. It's a delayed broadcast from millions or billions of years ago. So when the sun is gone, its presence still lingers in photons, in warmth, in memory. And when the night seems black, it's often just waiting for scattered sunlight, ancient starlight, and colours that never left. The sun may set, but its story goes on. What happens to light we can't see? Here's something strange. Most of the light in the universe isn't visible, not to us at least. Ultraviolet burns our skin, but we can't see it. Infrared warms our blankets, but we only feel it. Gamma rays pass through us. Microwaves carry messages. All of it is light, and all of it paints the universe in colours we never learned to name. Some telescopes can see those hidden layers. NASA's James Webb Space Telescope, for example, sees in infrared, revealing galaxies shrouded in dust. X-ray observatories see violent stars and black hole flares. Radio telescopes listen to the hum of quasars scattered across the sky. So when you look up and see black, you're not seeing nothing. You're seeing a small part of everything, a sliver, a slice. And the rest? It's not gone. It's whispering all around you, through walls, through air, through your bones. It doesn't need eyes. It doesn't need permission. It just moves. The sky is never dark. It's just written in invisible ink. The sky through animal eyes. Now close your eyes for a moment and imagine you're not human anymore. You're a bee, a cat, an owl, a bat. Each one sees the sky differently. Bees see ultraviolet. They see patterns on flowers invisible to us. Cats and owls are built for low light. They can track movement in darkness we'd call black. Bats see through sound. Dolphins use sonar. Snakes sense infrared, which means the night sky is not one thing, it's 1,000 versions, and we just live in one of them. To a bird that sees magnetic fields, the sky may shimmer with direction. To a shrimp with 16 types of color receptors, the black of space may be a rainbow. And to a whale hearing deep in the ocean, the sky might sing instead of shine. So when we say, the sky is black, we're not describing the sky. We're describing ourselves, our biology, our limits, our lens. And ahead in this video, we'll keep peeling back that lens, exploring how ancient light survives, how silence isn't so silent, and how the darkest parts of the sky are quietly full of motion. Cosmic microwave background, the faint glow of creation. Let's go back, not just a few years or centuries, but all the way back to the very first light that ever existed. About 13.8 billion years ago, the universe was hot, unimaginably hot, so dense and bright that no atoms could form, just energy and particles, dancing, colliding, glowing. But then, everything cooled, and in that cooling something beautiful happened. Atoms formed. Light was finally free to move, to travel. That light is still traveling, right now. It's everywhere, all around you. A faint ancient glow, stretched by time until it's now microwaves. It's called the cosmic microwave background. This light is so gentle we can't see or feel it. But it's there, a baby picture of the universe, glowing softly in every direction. And scientists have photographed it, mapped it, listened to its hum. So the sky above you tonight? It still carries the memory of the universe's first breath. The darkness is an echo, a warm afterglow from when everything began. And that glow, it never left. It just changed clothes. Why light takes so long to arrive? Let's talk about patience, because when it comes to light, the universe teaches us how to wait. Light may be fast, the fastest thing we know, but space is vast, and light still has to travel. A star you see tonight might be 100 light years away. That means the glow in your eye left that star 100 years ago, before you were born, before electricity reached your town, before your grandparents met. That starlight has been travelling all this time just to meet your gaze, and it almost missed you. 1 degree to the left, one planet not there, and it would have passed forever unnoticed. Some light takes even longer. A galaxy 10 billion light years away, you're seeing it as it was before Earth even formed. You're looking into the past through a telescope made of your own pupils. So when you see a black sky, you're actually in a moment between moments. Some light has left. Some is still on its way. You're standing in a cosmic hallway, waiting for the doorbell of a star's memory to finally arrive. And the wait? It's always worth it. The universe is full of colour, just not our kind. Colours are real, but they're also personal. What you call blue, someone else might call grey. What your dog sees as dull, a bird might see as neon. Now imagine the universe. Vast, mysterious, bursting with energy, but filtered through our limited colour vision. Our eyes detect 3 main wavelengths, red, green and blue. That's it. So most of the colours in space, we'll never see them, but they're there, hidden in X-rays, painted in infrared, singing in ultraviolet. Some stars give off energy we'd call violet, but our eyes don't reach that far. So instead of purple skies, we see black. If our eyes could stretch just a little more, just 1 octave higher or lower, the night sky would shimmer like a cosmic rainbow. Dust clouds would glow red. Nebulae would pulse with blues and greens. Entire galaxies would swirl in unseen hues. So the sky's not black. It's just coloured in crayons we never had. And as we open more of this story, you'll begin to see those colours in your imagination where no spectrum limits you. Seeing with radio eyes, now let's listen to the stars. Not with ears, of course, but with telescopes that hear in waves. Radio waves are a kind of light, just stretched out, long, gentle, rolling through space like ocean swells. We don't see them, we don't hear them, but they're everywhere. Pulsars spin and send out steady beacons. Quasars scream across billions of light years. Even the Milky Way itself glows in radio light. When astronomers point radio telescopes at the sky, they reveal a universe that looks nothing like the one we see. Galaxies become clouds. Invisible jets shoot from black holes. Entire constellations vanish, and new ones appear. It's like turning the lights off in a room and discovering the walls are singing. Radio light doesn't care what our eyes want. It moves silently, softly, revealing a world just beneath the skin of sight. So when you think of the night sky, pause. You're only seeing one version, but overhead there's a quiet song of the cosmos, still playing, still glowing, in waves we'll never feel, but always love, the glow of infrared stars. Let's turn up the heat, not to feel warmth, but to see it. Because some stars don't shine in visible light, they shine in infrared, the light of warmth. Infrared stars are cooler, gentler. They burn red and low, like the final coals of a campfire. Our eyes miss them entirely. But infrared telescopes, they see a galaxy full of hidden giants. These stars often sit in dusty places where visible light gets blocked. But infrared slips through. It reveals baby stars being born. It finds galaxies hidden behind veils. It lights up the skeleton of the universe where everything is still forming. Even your own body glows in infrared. Your face, your hands, your heartbeat. If you could see in this light, you'd never see the sky as black again. You'd see your own heat reflecting softly off the air and stars glowing like embers in the cold. So the sky doesn't stop glowing when you sleep. It just moves into a different language. And in the chapters ahead, we'll uncover more of that quiet, radiant language, written not in blackness, but in warmth, in history, in glow. Space dust that paints with shadow. Space isn't as clean as it looks. Between the stars, there's dust, tiny grains, older than Earth, scattered like ash from 1,000 ancient fires. This cosmic dust doesn't block light completely, it plays with it, bending it, scattering it, softening sharp edges and painting shadows across galaxies. Sometimes it hides newborn stars in warm golden blankets. Other times it stretches across the sky as long cold wisps called nebulae. When we look at a star through dust, it seems redder, fainter. That's called interstellar reddening, a trick of distance and dirt. The star isn't red, it's just seen through a stained glass window of the cosmos. And when the dust is thick enough, it creates what we call dark patches in the sky, silent places with no stars. But the truth, those stars are still there, hidden behind soot glowing quietly through the veil. So even the blackest part of the sky might be crowded with light. The dust doesn't erase it. It just delays the reveal, like a slow curtain on a faraway stage. And in the next part of our journey, we'll open that curtain a little more. The universe in ultraviolet. Let's shift again, this time into a sharper, higher light. Ultraviolet, the kind you can't see, but your skin can feel. Most of us think of UV light as something that causes sunburns. But in space, ultraviolet light is a blazing language of heat and power. Hot young stars shine brightest in UV. They glow like blue torches, invisible to us but dazzling in space. Ultraviolet telescopes reveal star-forming galaxies, fierce, fiery cradles full of newborn suns. They show regions where gas is ionized and blazing, where stellar winds ripple space like sails in a storm. Entire clusters of stars that look quiet in visible light turn wild and bright in UV. But Earth's atmosphere blocks most ultraviolet light from reaching us. That's good for our skin, but it means our eyes miss the fireworks. From orbit, however, satellites like GALEX have captured these hidden pyrotechnics. So the night sky, seen in ultraviolet, is anything but dark. It's filled with roaring stellar nurseries, invisible to us, but always burning, always creating. And as we drift further, we'll explore even more extreme light, where brightness becomes danger and silence becomes energy. The X-ray sky bursts and whispers. Now we enter one of the strangest layers of light. X-rays, not just the kind you find in hospitals, but the kind that scream silently across the universe from some of its most violent places. Exploding stars, colliding black holes, neutron stars spinning like sirens, galaxies with hearts of fire. X-ray telescopes like Chandra and New Star show us a night sky we could never imagine. One where galaxies don't twinkle, they flare. Where black holes don't hide, they shine with ghostly halos. Where what looks dark is actually the brightest of all. But you'll never see X-ray light with your eyes. Not here on Earth. It's filtered out long before it touches your skin. So we build eyes in orbit, satellites that show us what the sky really looks like when it's furious, alive, and ancient all at once. Some of these bursts last milliseconds. Some echo for years, and all of them are invisible, unless you know how to listen. So next time you see a patch of sky that looks silent, remember, it might be whispering in X-rays, and we've only just learned to hear. The eyes of telescopes versus our own. Let's be honest, human eyes are wonderful, but when it comes to the universe, they're a bit outdated. We see what evolution needed us to see. Predators, berries, sunlight, danger. But telescopes, they're built for curiosity. They don't blink, they don't sleep, they don't miss the colours we miss. A telescope isn't just a bigger eye, it's a better translator. It can see infrared warmth, ultraviolet fire, X-ray bursts, and radio whispers, all stitched together into images we can finally understand. That's why NASA colors telescope images, not to lie, but to help us see what we otherwise never could. Every color tells a story: heat, motion, element, distance. False color doesn't mean fake sky. It means true structure, through different eyes. So when we look up and see black, telescopes see galaxies, dust, fields of invisible energy. To us, the sky is quiet. To them it's busy, chaotic, beautiful. And as we near our next chapter, we'll hear from those who've really seen it, those who've floated beyond our blue blanket and looked directly into the mystery. Why astronauts don't see darkness. Here's something surprising. Astronauts, the very people who leave our planet, don't describe space as black. They say it's layered, glowing, deep, sometimes even overwhelming. Imagine being wrapped in infinite navy blue velvet, not nothingness, but depth, a kind of presence you can't explain. When you orbit Earth, you see cities glow. You see auroras dance in ribbons of green and violet. You see thunderstorms flickering across continents. But even away from the planet, beyond the clutter of satellites, the void still hums. Some astronauts report seeing faint flashes, cosmic rays zipping through their retinas. Others say their sense of time breaks down, that the stars are so clear they no longer feel like distant specks, but neighbours. They don't describe space as black. They describe it as endless, full, reverent. And in the chapters ahead, we'll shift from what we can't see to what's always been glowing, gently, patiently, behind the curtain of night. Because the story of the sky isn't about what's missing, it's about what's waiting. What is darkness, scientifically? Let's take a pause and ask something quiet. What exactly is darkness? Is it a thing or the absence of something? In science, darkness isn't a substance. It's not made of particles or waves. It's simply where visible light isn't. But that definition hides how strange it really is, because in the universe, almost no place is truly absent of light, not even black holes, not even space itself. What we call dark is just a failure to detect, a boundary of our senses. When light is too faint, too stretched, or too energetic for our eyes to catch, we call it black. But light doesn't care what we see. It still moves, still radiates, still dances unseen. Darkness isn't evil. It's not empty. It's just quiet. It's the pause between photons, the soft in-between where vision gives up, but reality goes on. And sometimes that's the most honest place to look, the space where nothing shines for us, but everything still exists. The night sky isn't darkness. It's dimmed brilliance. You just need a wider lens. Ahead, we'll explore just how softly that light continues, even where it seems long gone. The sky is never off, just dimmed. Have you ever left a room and thought you turned the light off, only to come back later and realize it was just very dim? That's the sky. We think it goes off at night, but really, it's still on, just quieter, dimmed by distance, hushed by time, muffled by biology. The stars don't sleep, the galaxies don't pause, even the empty parts of space glow with something. There's a soft ambient light everywhere. Even in intergalactic space, between galaxies, there are rogue photons, lonely starlight, faint microwave echoes. Sometimes they pass through us without ever being noticed. Even the molecules in the air above you scatter light all night long. It's just too faint for your eyes. But with long exposures, cameras reveal it. The sky glowing in colours you've never seen. The blackness of space, gently lit like a candle from 10 rooms away. So the sky doesn't turn off. It just gets subtle, like a whisper in a dream you almost remember. The show never ends. We just close our eyelids and forget we were in the audience. And up ahead, we'll see just how old that light really is. Starlight from the past. When you look at a star tonight, you're not seeing it as it is. You're seeing it as it was. Because light takes time to travel, every star in the sky is a memory. Some are 10 years old. Some are hundreds. Some are thousands. When you look up, you're looking back, through time, not just space. A star that exploded 1,000 years ago might still shine in your sky, simply because its final light is still arriving. That's the strange romance of astronomy. It's always about the past. Even the moon is slightly delayed, just over a second away in light. So when the sky seems quiet and black, it's not. It's telling stories. The photons in your eye tonight may have been born before the pyramids, before humans walked upright, before Earth had flowers. The sky is not just high above, it's deep behind, a library without walls, and every star is a letter written across centuries. Soon we'll ask, if everything we see is old, what happens when light never gets here? Olber's paradox. Why isn't the sky blindingly bright? Here's a strange thought from an old question. If the universe has infinite stars in every direction, why isn't the sky white? That's called Olber's paradox, and for centuries it confused scientists and philosophers alike. If stars stretch endlessly through space, shouldn't every line of sight eventually hit one? Shouldn't the night be ablaze with light? But it's not, and the reason is simple, beautiful, and cosmic. The universe is not eternal. It had a beginning, a starting line. That means light from the farthest stars hasn't reached us yet. The universe has a horizon, a limit to how far we can see, and it's expanding, which stretches light, redshifts it, fades it, stars burn out, their light dims. The sky isn't full of visible stars, because much of the light has either passed, hasn't arrived, or was never visible to begin with. So the night sky is dim, not because stars are rare, but because the journey of their light is still unfolding, and some lights will never reach us, which makes every photon we do see a tiny miracle. And next we'll meet the ones that almost arrive, but fall just short of being seen. The expanding universe dims the glow. Let's imagine something subtle. You're in a hallway, someone shines a flashlight toward you, but as they walk away, the light fades, not because it stops shining, but because it stretches, softens, weakens. That's what's happening to light in an expanding universe. As space itself stretches, the waves of light get longer. A blue glow turns red. A red glow turns infrared. Eventually, it slips into radio waves or vanishes beyond detectability. This stretching isn't because light is tired, it's because the space between us is growing, not just galaxies moving apart, but the fabric of space itself expanding. And that pulls light thin, like ink across an infinite canvas. That's why distant galaxies fade, why the farthest stars disappear, not because they stop shining, but because they shine in ways we can no longer see. So the sky isn't black from absence, it's black from motion. Light hasn't died, it's just been pulled beyond our reach. Like a song played at such a low frequency, we can no longer hear it. But it still plays. And in the next section of our journey, we'll meet light that loops, echoes, and hides just out of view. Light lost to time. Let's imagine a light that never finds its way home, not because it's gone, but because the universe has simply moved too far, too fast. There are photons, particles of light, still travelling across space from the earliest moments of the cosmos. Some have been drifting for billions of years, but they'll never reach us, not because we missed them, but because space itself stretched their path into impossibility. These are lights from galaxies so far away, moving faster than light can catch up. Their glow is racing outward, redshifted into invisibility, like whispers swallowed by a storm, and we'll never see them. Not now. Not ever. It's a strange sadness, isn't it? To think there are colours, events, entire galaxies that happened that still are, but we'll never witness them. Their light has been lost to time, but it's not really lost. It still moves, still travels, just elsewhere, to places we'll never reach, wrapped in silence, glowing for no audience. And yet, we can feel their absence, like a missing page in a book we can't quite finish. And that leads us gently to another mystery of distance. How dimness isn't always because of darkness, but because of drift. Why light fades in the void? Why does light get fainter over distance? It's not like it runs out. It doesn't weaken like sound. So, what actually makes it disappear? Here's the quiet truth. Light spreads. It radiates outward in all directions, and that spreading thins it like ink on an ever-growing canvas. Every second, every inch, it covers more space. Not weaker, just diluted. Imagine blowing up a balloon with dots of paint on it. As the balloon stretches, the paint spreads thinner and thinner until it's barely visible. That's what happens to light across the vacuum of space. And when you mix in the expanding universe, it doesn't just thin, it stretches. The light's colour shifts toward red, then infrared, then microwave. Eventually it becomes something entirely different than it was when it began. So when we look into the sky and say, it's black, what we mean is, it's too thin, too stretched, too faint to feel. But the light? It's still there, just spread so wide. We can't catch it. And in a few moments we'll uncover an even stranger idea. That darkness, the very thing we fear, might actually be a kind of mirage. Darkness as a mirage. Let's walk into a paradox. What if the darkness you see isn't really there? Darkness feels so solid, so final, like a wall. But in truth, it's often an illusion, a mirage caused by our limits, not the universe's. Our eyes, brilliant as they are, stop registering light below a certain level. But that doesn't mean the light stops existing. It just means we can't collect it. Not fast enough. Not in enough quantity. It slips between the cracks of our perception. Think of a very dim candle across a football field. You might not see it, but a camera with a long exposure will. The light didn't vanish. It was always there. You just didn't wait long enough. In space, this effect happens constantly. There's light all around us, in every direction, from galaxies, from background radiation, from scattered particles. But it's so spread out, so faint, that our minds paint black where glow actually exists. Darkness isn't always the absence of light. Sometimes, it's the absence of sensation, a kind of blindness we mistake for emptiness. And in the next moment, we'll meet the stars that should be visible, if only time had given us a little more. Stars that vanished before we saw them. Here's a quietly heartbreaking idea. Some stars you'll never see, not because they're too far, but because they're already gone. Imagine a star that lived for 10 million years, glowing with cosmic beauty, but it exploded 1 million years ago, and the last light it ever sent is still travelling to Earth, slowly, delicately, like a ghost in the wind. You might spot it in your telescope tonight, but that star? It's dust now, a memory, a shimmer in the past. You're seeing its final breath. And even more haunting, there are stars whose light hasn't even reached us yet. Stars being born right now, tucked inside nebulae, whose first beams will take hundreds of thousands of years to arrive. We live in a sliver of sky, always behind, always delayed. So the stars you wish upon may already be gone, and the stars that would have comforted you haven't yet arrived. That's how time dances in the night. The sky isn't a snapshot, it's a mosaic. Some tiles are from yesterday, some from before Earth existed, some haven't been added yet, and ahead we'll visit the very oldest light of all, not from stars, but from the beginning itself, the whisper of ancient photons. At the edge of everything, there's a glow, faint, uniform, older than stars, older than galaxies, older than memory. It's called the cosmic microwave background, or CMB, the afterglow of the Big Bang, the first light that could ever travel freely 13.8 billion years ago. These photons have been drifting across the expanding universe since time was seconds old, stretched into microwaves, chilled almost to absolute zero, but still moving, still arriving, still visible. If you know how to see, it was discovered by accident, a quiet hiss in a radio antenna in 1964. At first, scientists thought it was static, interference, pigeon droppings, but no, it was the voice of creation, whispering to us from across eternity. Every part of the sky, even the darkest, is soaked in this ancient light. It wraps Earth, passes through you, fills your room right now, not blinding, not loud, but constant, patient, honest. It is proof that the sky has never been black, not even once. And as we wander forward, we'll see how time, distance, and perception keep that ancient glow hidden. Even though it's all around us, you're always surrounded by light. Let's stop right here and sit with something quietly astonishing. You are never in the dark. Not really. Not even now. Even in a pitch-black cave, even in the deepest part of night, light is still touching you. From stars, from galaxies, from the ancient microwave glow of the Big Bang, from your phone, from the walls, from your own body. Infrared light radiates from your skin, soft warmth invisible to your eyes but alive in the world. Ultraviolet rays from stars glide through your window by day. Cosmic rays streak through your body every second, gifts from exploding stars. Darkness is a word for what we don't register, but the world doesn't stop just because we blink. Photons still move, still bounce, still carry heat and information and memory. And you, right now as you breathe, are glowing, just not invisible light. You are a little lighthouse, surrounded by signals and softness. So the next time you feel swallowed by night, remember, the universe is always lighting your way, even if your eyes can't see it. And ahead, we'll discover how your mind plays along in this illusion. Your eyes are built for contrast. Here's a secret your brain never tells you. You don't actually see light. You see changes in light. Your eyes are contrast detectors. They're constantly comparing. One spot to another, one shadow to the next. That's why a dim candle in a dark room feels brighter than the same candle in daylight. It's not the candle that changes. It's your context. When the entire sky dims, your brain resets its baseline. It decides quietly, this is dark. But the actual light hitting your eyes hasn't stopped. It's just evened out, smoothed, flattened. Your perception plays a trick. It's also why stars sparkle more on a black canvas. Your eyes highlight the differences. They exaggerate the stars and erase the space in between. But the light is still there, gently filling the gaps. You are a creature of contrast, biologically tuned to notice edges, shifts, flickers. And so when everything dims together, your brain erases the details, like a painter wiping the board clean. But the universe never stops painting, and in the coming chapters, we'll see how invisible light keeps coloring your world in ways you've never noticed. Radio waves. Paint the sky differently. Let's tune our senses to a different kind of seeing. Imagine having eyes that could detect radio waves. If you could see in radio, the night sky would look completely different. The moon would nearly disappear. The Milky Way would glow in long, streaky tendrils. And enormous structures, jets from black holes, interstellar clouds, collapsing stars, would stretch across your vision like living sculptures. Radio light isn't just for music or phones. It's cosmic. It's old. And it fills the sky like a soft hum beneath everything. Giant radio telescopes like those in Arecibo or the VLA don't listen. They see in wavelengths far beyond our human reach. And what they see is breathtaking, a sky full of structure, warm clouds that never look like clouds, supernovae still echoing across light years, invisible beacons from pulsars flickering like lighthouses in the void. To our eyes, these things don't exist, but to radio eyes, the universe is richly alive, never black, always humming, and ahead, we'll meet the colours that sneak into our lives through other hidden windows. Infrared, the warm light, we never see. Now let's step into warmth. Not heat you feel with your skin, but light that glows without glowing. Infrared is just below red in the colour spectrum, a longer wavelength than your eyes can detect. But every warm object emits it. Your pillow, your breath, the trees, your tea, your hands right now. Night vision goggles see in infrared. So do satellites, snakes, and some insects. If you could see it, the world would shimmer with heat outlines, footsteps on floors, warm hands on cooler tables, the outlines of clouds in a moonless sky. Astronomers use infrared to peek through dust clouds that hide baby stars. It reveals things that visible light can't, and it's all around us, quietly mapping the warmth of existence. So while your eyes rest, your surroundings are glowing. Every room, every corner, even the sky above you, even now, is softly bleeding infrared light from galaxies beyond your imagination. And soon, we'll meet the light that flies faster than sight, born in explosions that change the universe. Gamma rays and X-rays, the universe's sharpest light. Let's now explore the most intense light of all, the light we never see, but that shapes stars, planets, even life. Gamma rays and X-rays are high-energy photons, unimaginably powerful. They're born in the heart of exploding stars, in the violent birth of black holes, in the crush of neutron stars colliding. They can slice through entire galaxies, pass through flesh, burn sensors. We shield ourselves from them with lead. We hide behind Earth's atmosphere, nature's blanket of protection. But above it, satellites detect bursts of gamma rays from billions of light years away. Each burst tells a story of creation and collapse, and yet we never feel them, never see them, never hear them. Like silent thunder, they pass us and move on, but their effects shape the universe. Without them, stars wouldn't die in spectacular supernovae. Planets wouldn't get seeded with heavy elements. The sky itself wouldn't be the same. Even in their invisibility, gamma rays remind us. The blackness we think surrounds us is simply light we're not yet able to touch. And in the next moments we'll gently enter the final truth, that the universe is never still and never truly dark. The night sky changes while you sleep. Close your eyes for a moment, and when you open them again, the sky will have moved. Even as you lie in bed, the earth spins, quietly, steadily, carrying you in a slow circle through the universe. Stars shift, constellations rotate, planets wander, but it happens so slowly, most never notice. If you set a camera to take long exposure photos while you sleep, you'd see it. Gentle arcs of starlight circling the North Star like brushstrokes on a dark canvas. The sky doesn't stand still, it dances. And as seasons pass, entirely new constellations rise. Orion disappears, and Scorpius takes its place. It's not just the Earth's spin, it's our orbit, a full revolution around the Sun every 365 days. A silent circular migration of the night. You may think you're looking at the same black sky every night, but you're not. It's changing, quietly, gently, every second. And up ahead, we'll wander into the deep truth that your position in space determines what you call darkness. Darkness depends on where you're standing. If you stood on the moon, would the sky still be black? Surprisingly, yes, but only if you looked away from the sun. On the moon, there's no atmosphere to scatter light, so shadows are pitch black and the stars never twinkle. There's no blue sky, just silence and blackness, even in full daylight. Now imagine floating between galaxies far from any star. No planets, no moons, just the raw canvas of deep space. There too the sky would look black, but this blackness wouldn't mean emptiness. It would mean isolation. And yet, if you had the right eyes, radio eyes, gamma eyes, microwave eyes, you'd see it all. Galaxies, clouds, light older than time. Your perception defines your darkness. The idea that dark is universal is a little illusion. Darkness depends on where you're standing, what you're facing, and what your senses are built for. And in just a moment, we'll follow how ancient humans once looked into this same sky and saw fire, gods, and forever. Ancient people saw light in the darkness, long before telescopes, long before science. The night sky was a temple. Our ancestors stared up and didn't see emptiness. They saw presence, figures, stories, gods, lions and hunters and serpents. They wove meaning into stars and carved wisdom into the spaces in between. They noticed that some stars moved, planets, that others flickered and vanished, novae. That comets came like omens. They didn't call it black, they called it mystery. In many traditions, the night wasn't a void. It was the womb of creation, a sacred darkness, alive with possibility. The Milky Way was the road of souls, or the backbone of the sky. And even when they feared the dark, they filled it with story. They lit fires, sang to it, named its stars like family. No one stared into the void and saw nothing. They saw everything they needed. And in this next part, we'll quietly explore how space scientists today still carry that wonder, just wrapped in different language. Modern telescopes reveal invisible light. Today's astronomers aren't just looking at stars. They're looking at light you'll never see. In space observatories like Hubble, Chandra, Webb, and ALMA, we peer through infrared, ultraviolet, radio, and X-ray. We layer these different wavelengths into colorized images, creating a sky humans were never meant to see, but always hoped to. These aren't just pretty pictures, they're revelations, galaxies colliding, black holes spinning, nebulae forming like petals in zero gravity. They teach us how stars are born and how the sky is never silent. Even black patches of sky reveal hundreds, sometimes thousands, of galaxies when observed long enough. These ultra-deep field photos are proof. The darker it looks, the more it holds. Modern science has not erased the magic, it's expanded it, translated mystery into measurement and awe into data. But the heart of it is the same. We still stare into the unknown and feel the tug of curiosity. And soon, we'll bring this all home, to your window, your pillow, your breath, the night sky in your own room. Let's close your eyes, but leave your mind gently open. The light from distant galaxies is still drifting through your walls. The cosmic microwave background, that whisper from the Big Bang, is brushing past your blanket. Your body is glowing in infrared. Your phone emits microwaves. Your breath is warm with photons. The night sky never left. It has entered your room. The same starlight that touched Galileo, Cleopatra, ancient shamans, and forgotten wanderers now glows inside your space. Faint, invisible, but there. You may not see stars from your window tonight. Maybe the clouds are in, maybe the lights are too bright, but you are still connected to the sky. You are part of the sky. Your atoms were made in stars. Your heartbeat ticks to the rhythm of cosmic time. You are the universe, briefly looking back at itself. And as we drift deeper into this bedtime voyage, we'll discover that black was never a colour, but a story your mind once told. Space is not black, just subtle. If you could paint space with a true brush, you'd run out of black faster than you think. The idea that space is black is a trick of our senses, a limitation of the narrow slice of wavelengths we call visible light. But light doesn't end there. It just slips beyond our eyes. It becomes longer, fainter, warmer, older. Infrared glows from every warm thing. Radio waves stretch through the dark like whispers. Ultraviolet burns through gas clouds like invisible fire. X-rays scream from distant violence. The colours are there, they just hide in unfamiliar coats. Space is filled with texture, temperature, and time. But without the eyes to receive it, it pretends to be black. It's like a library with no readers, silent but not empty. Astronomers have built eyes to see these hidden colours, telescopes that reveal the subtle gradients of the cosmos, the soft veiled beauty of what once looked blank. And next, we'll slow down to wonder, if space is full, what is it full of? When nothing is actually full, there's a strange, quiet truth hidden in the darkness. Space, the so-called void, is not empty. Not at all. What looks like nothing is teeming with energy. Quantum fields ripple through the vacuum. Virtual particles flicker in and out of existence. Entire galaxies, too faint to be seen, drift across our blind spots. Even the emptiest space still contains the echo of the Big Bang, the cosmic microwave background, still contains gravity, still carries radiation, still bends light, still has structure. We think of black as an absence, but in science, black is often a curtain. Behind it, mystery. Behind it, movement. Behind it, the everything we haven't noticed yet. If you flew between galaxies, far from stars or gas or planets, and measured that nothing, you'd still find the fingerprints of creation written there in temperature, motion, and possibility. And soon we'll explore how even the most invisible forms of light leave traces all around you. Invisible light, all around you. Let's turn away from space and look around your room, because what you think is dark isn't. Your walls reflect infrared, your skin emits it, your phone glows with radio light. The Wi-Fi router hums in waves you can't see. If you had eyes for microwave or ultraviolet, your ordinary life would become a glowing jungle. Some animals do see this way. Bees can spot ultraviolet targets in flowers. Snakes sense infrared to hunt in the night. Mantis shrimp see a rainbow. Humans can't even imagine. What we call visible light is just a thin slice, a razor-thin line in a vast cosmic symphony. Most of the light that exists is simply not for us, but it's there, always, shining silently. And as we drift into the deeper story of space, we'll begin to ask, if all this light is real, what about the darkest places we know? The sky has texture. We can't feel. Now, imagine you could touch the sky. What would it feel like? Science says, not smooth, not flat, not blank, but full of bumps, waves, curves, and distortion. Space is textured, not by matter, but by gravity and time. Massive objects bend light. They stretch space. They warp the path that photons take. This warping, known as gravitational lensing, lets us see things we could never detect directly. Galaxies magnified by foreground clusters. Light bent around invisible mass. A shadow revealing what even a telescope cannot. And yet, to our eyes, it still looks black, empty, untouched. But that's the illusion. The truth is underneath, a soft sculpture of space-time gently cradling all light that passes through. So as you drift off tonight, know that above your ceiling, above the clouds, above the stars, space is rippling like water, gently, eternally, waiting to be seen in the right light. And as we move forward, we'll enter the strangest place of all, where even light disappears. Black holes that radiate. What could be blacker than a black hole? And yet, even they shine. It was once thought that black holes were pure nothing, points of no return, swallowing all. But then came a strange whisper from Stephen Hawking, suggesting they radiate, that they glow, that they slowly, invisibly evaporate. This radiation isn't warm or bright. It's faint, quantum, born from the tension between gravity and uncertainty. But it means that even the darkest thing in the universe cannot stay black forever. A black hole's darkness is not a colour. It's a condition. It's about escape velocity, about how no light can climb free. But inside, particles still swirl, temperatures rise, energies collide. Even the most silent darkness eventually sings. So as we travel deeper into the final parts of our journey, we'll discover that Black is not the absence of light, but the outer shell of something waiting to shine. Dust that reflects light across centuries. Out there, scattered between stars, floats something ancient, fragile, and glowing in disguise. Interstellar dust, tiny particles smaller than sand, float quietly through space. They're born from dying stars, from cosmic winds, from explosive endings and soft beginnings. And though they're dark up close, they shimmer from afar. These grains don't emit light, they reflect it, or absorb it, and re-radiate it in longer wavelengths. That means a star that died 100 years ago might still be lighting up a distant cloud of dust right now. Even the blackest space can carry echoes of a long-gone star, in a faint glow bouncing off microscopic dust. Some of the light we catch is not direct, but borrowed. And just like how fog turns headlights into halos, these clouds transform starlight into something softer, more diffused, more poetic. And in the next breath, we'll wander into a stranger place still, where light curves, loops, and bends like liquid silk. Light that loops around gravity. You'd think light travels in straight lines, but not in this universe. Gravity, especially from massive objects like galaxies and black holes, doesn't just pull on matter, it bends space-time itself. And when light travels through curved space, it curves too. Imagine a single beam of light circling a black hole, caught in orbit, tracing a perfect loop. It's called a photon sphere. The idea that light, which seems so free, could be trapped in orbit is hauntingly beautiful. There are places in the cosmos where a single galaxy behind another appears stretched into rings. These are Einstein rings. Light from a distant source bending completely around a massive foreground object. We can even see galaxies multiple times in one picture, their light taking different curved paths to reach us. The sky becomes a hall of mirrors, reflections of a universe wrapped in gravity's embrace. And now, as we close our eyes, we'll visit the trickiest illusion of all, the one born from inside our own minds. How we're tricked by our own eyes. Sometimes, it's not the sky that fools us, it's us. The human eye is a miracle, but also deeply limited. Our brains fill in gaps, they smooth shadows, they brighten edges. They try to make sense of chaos with familiar shapes and known patterns. When we look at the night sky, we see twinkling stars. But that's an illusion caused by the atmosphere. We see black between stars. But our eyes aren't sensitive enough to notice faint background light. We believe we're seeing emptiness, but we're not. Even the color black isn't truly a color in physics. It's the absence of visible light. But when you close your eyes and press gently, you'll still see patterns, swirls, faint glows. Your brain keeps trying to see. This means the darkness we believe surrounds us is partly invented, a trick of biology, a quiet filter applied by our senses to help us cope with infinity. And soon we'll revisit that quiet idea, that even nothingness has something to show us. Why seeing nothing is actually seeing something. Have you ever stared into a deep, empty field of sky and felt like something was watching back? It's a quiet trick of consciousness. When we look at nothing, when we truly gaze into a patch of sky with no stars, no moon, no clouds, what we're actually doing is searching, interpreting, projecting. Our brains don't enjoy blankness. They seek structure, they compare contrast, so even in blackness, we start to detect subtle gradients, faint motion, implied depth. It's not hallucination, it's attention. And in astronomy, blank patches of sky often turn out to be the most full. The famous Hubble Deep Field, aimed at what looked like an empty void, revealed thousands of galaxies stacked in layers of ancient light. The idea that nothing exists is increasingly fragile. Even quantum physics suggests that what we call vacuum is buzzing with uncertainty, virtual particles, and hidden potential. So when you next look up and see nothing, take another breath. You're not seeing absence, you're seeing the edge of knowing. And to close this chapter set, we'll return to the only place where sky becomes personal, your own perception, why the black sky is a reflection of you. Let's say something soft here. The blackness you see is partly you. It's your biology, your brain, your conditioning, and your poetic interpretation, all creating an experience, a subjective painting on the canvas of your inner self. That sky is filtered through your story. To a child, it might feel endless. To a lover, romantic. To a dreamer, full of stars yet to be named. To a scientist, it's full of data. To someone heartbroken, it might feel cold, and yet the sky hasn't changed. Only you have. And in that way, the black sky is not universal. It is intimate. It reflects what you carry. So tonight, as you fall asleep to this soft rhythm of science and wonder, let the darkness wrap you gently, not as a threat, but as a vast, star-dusted mirror. And ahead in this journey, we'll follow that mirror into places more emotional, more ancient, and more connected to light than you've ever imagined. Dust that reflects light across centuries. Out there, scattered between stars, floats something ancient, fragile, and glowing in disguise. Interstellar dust, tiny particles, smaller than sand, float quietly through space. They're born from dying stars, from cosmic winds, from explosive endings and soft beginnings. And though they're dark up close, they shimmer from afar. These grains don't emit light, they reflect it, or absorb it, and re-radiate it in longer wavelengths. That means a star that died 100 years ago might still be lighting up a distant cloud of dust right now. Even the blackest space can carry echoes of a long-gone star, in a faint glow bouncing off microscopic dust. Some of the light we catch is not direct, but borrowed. And just like how fog turns headlights into halos, these clouds transform starlight into something softer, more diffused, more poetic. And in the next breath, we'll wander into a stranger place still, where light curves, loops, and bends like liquid silk. Light that loops around gravity. You'd think light travels in straight lines, but not in this universe. Gravity, especially from massive objects like galaxies and black holes, doesn't just pull on matter, it bends space-time itself. And when light travels through curved space, it curves too. Imagine a single beam of light circling a black hole, caught in orbit, tracing a perfect loop. It's called a photon sphere. The idea that light, which seems so free, could be trapped in orbit, is hauntingly beautiful. There are places in the cosmos where a single galaxy behind another appears stretched into rings. These are Einstein rings, light from a distant source bending completely around a massive foreground object. We can even see galaxies multiple times in one picture, their light taking different curved paths to reach us. The sky becomes a hall of mirrors, reflections of a universe wrapped in gravity's embrace. And now, as we close our eyes, we'll visit the trickiest illusion of all, the one born from inside our own minds. How we're tricked by our own eyes. Sometimes, it's not the sky that fools us. It's us. The human eye is a miracle. Even the color black isn't truly a color in physics. It's the absence of visible light. But when you close your eyes and press gently, you'll still see patterns, swirls, faint glows. Your brain keeps trying to see. This means the darkness we believe surrounds us is partly invented, a trick of biology, a quiet filter applied by our senses to help us cope with infinity. And soon we'll revisit that quiet idea, that even nothingness has something to show us. Why seeing nothing is actually seeing something. Have you ever stared into a deep, empty field of sky and felt like something was watching back? It's a quiet trick of consciousness. When we look at nothing, when we truly gaze into a patch of sky with no stars, no moon, no clouds, what we're actually doing is searching, interpreting, projecting. Our brains don't enjoy blankness, they seek structure, they compare contrast. So even in blackness, we start to detect subtle gradients, faint motion, implied depth. It's not hallucination, it's attention. And in astronomy, blank patches of sky often turn out to be the most full. The famous Hubble Deep Field, aimed at what looked like an empty void, revealed thousands of galaxies stacked in layers of ancient light. The idea that nothing exists is increasingly fragile. Even quantum physics suggests that what we call vacuum is buzzing with uncertainty, virtual particles, and hidden potential. So when you next look up and see nothing, take another breath. You're not seeing absence, you're seeing the edge of knowing. And to close this chapter set, we'll return to the only place where sky becomes personal, your own perception. Why the black sky is a reflection of you. Let's say something soft here. The blackness you see is partly you. It's your biology, your brain, your conditioning, and your poetic interpretation, all creating an experience. A subjective painting on the canvas of your inner self. That sky is filtered through your story. To a child, it might feel endless. To a lover, romantic. To a dreamer, full of stars yet to be named. To a scientist, it's full of data. To someone heartbroken, it might feel cold, and yet the sky hasn't changed. Only you have. And in that way, the black sky is not universal. It is intimate. It reflects what you carry. So tonight, as you fall asleep to this soft rhythm of science and wonder, let the darkness wrap you gently, not as a threat, but as a vast, star-dusted mirror. And ahead in this journey, we'll follow that mirror into places more emotional, more ancient, and more connected to light than you've ever imagined. Dust that reflects light across centuries. Out there, scattered between stars, floats something ancient, fragile, and glowing in disguise. Interstellar dust, tiny particles, smaller than sand, float quietly through space. They're born from dying stars, from cosmic winds, from explosive endings and soft beginnings. And though they're dark up close, they shimmer from afar. These grains don't emit light, they reflect it, or absorb it, and re-radiate it in longer wavelengths. That means a star that died 100 years ago might still be lighting up a distant cloud of dust right now. Even the blackest space can carry echoes of a long-gone star, in a faint glow bouncing off microscopic dust. Some of the light we catch is not direct, but borrowed. And just like how fog turns headlights into halos, these clouds transform starlight into something softer, more diffused, more poetic. And in the next breath, we'll wander into a stranger place still, where light curves, loops and bends like liquid silk. Light that loops around gravity. You'd think light travels in straight lines, but not in this universe. Gravity, especially from massive objects like galaxies and black holes, doesn't just pull on matter, it bends space-time itself. And when light travels through curved space, it curves too. Imagine a single beam of light circling a black hole, caught in orbit, tracing a perfect loop. It's called a photon sphere. The idea that light, which seems so free, could be trapped in orbit, is hauntingly beautiful. There are places in the cosmos where a single galaxy behind another appears stretched into rings. These are Einstein rings, light from a distant source bending completely around a massive foreground object. We can even see galaxies multiple times in one picture, their light taking different curved paths to reach us. The sky becomes a hall of mirrors, reflections of a universe wrapped in gravity's embrace. And now, as we close our eyes, we'll visit the trickiest illusion of all, the one born from inside our own minds. How we're tricked by our own eyes. Sometimes, it's not the sky that fools us, it's us. The human eye is a miracle, so maybe the reason the night sky isn't scary is because we are meant to find comfort in it, like a universal signal that says, "Rest now. You've wandered far enough today." And as we soften into this idea, we'll remember that we are not strangers to light. We are light. You are made of light catchers. You are more than skin and bone. You are built from stardust and eyes that catch ancient light. Every atom in your body came from a star that once burned and died. Your eyes are lenses, your mind a translator, your heart a rhythm that responds to sunrise and moonlight. Inside your eyes are rods and cones, little biological sensors designed to catch photons. Some are sensitive to brightness, others to colour. All of them work together to form your view of the world. But here's the most poetic part. The light that enters your eye touches your soul. It becomes your experience. You don't just see it, you feel it. You remember it. You attach emotion to it. Light becomes memory. So the next time you look into the blackness above, remember, the fact that you see it at all means you're not in the dark. You're dancing with particles older than planets. And speaking of light, some of it never left. It's still out there, softly glowing, even if its source has long faded. Every star you see is a story. Look up. That flickering point isn't just a star, it's a story. Some of those stars are so far away. The light reaching you tonight began its journey hundreds, even thousands of years ago. The star itself may have already dimmed, died, or changed. But the light, the story, is just arriving. You are seeing history, directly. No telescope required. You're not seeing how things are, you're seeing how they were. You're watching ancient messages cross time and space to land in your quiet eyes. Each star has its own life. Birth, burning, change, and eventual fading. Some become giants, some collapse, some explode, some just cool quietly, unnoticed. And each moment of that story sends out light. So when you lie back under a black sky and a single point winks down at you, know that you're witnessing an echo, a gentle memory in the form of light. And that memory, for just a second, becomes yours. And as we continue, we find that this echo never truly fades. The universe is still glowing. Even if you turned off every star, the universe would still glow. It glows in microwave radiation from the Big Bang. It glows in the gentle warmth of dust, in the background hum of galaxies too faint to count, in the infrared hiss of heat escaping planets, in the X-ray bursts of dying things. This light isn't always visible. It's often not bright, but it's there, quietly stretching, travelling, being. The universe doesn't know how to stop glowing. It simply keeps radiating its existence. Every patch of sky, even one that looks pitch black, holds countless hidden beams. It's never empty, never off, never silent. The glow may be subtle, but it is relentless. And tonight, as you lie in your room, you are surrounded by it, bathed in it, touched by the very oldest light that still remembers the beginning. Ahead in this story, we drift into the final quiet chapters, where black becomes softness, silence becomes song, and your place in the sky becomes personal again,